Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry the Mystery of Molecules. Today's topic of discussion is Oxone. It's a very famous oxidizing agent. So today we shall discuss its preparation, reactivity, lots of things. So let's start. Before going to details, one MCQ. What is Oxone? Okay, I know it's a very easy question. So 5 options are provided. I request you please pause the video and write your answer in the comment box. And remember, self-evaluation is essential for improvement. Now let's go to the main topic. Oxone versus potassium peroxymonosulfate. Because majority of time you will see that oxone is equivalent to potassium peroxymonosulfate. Is it same? Actually, they both are not same because oxone is a triple salt. I repeat, it's a triple salt, and this peroxymonosulfate is only the salt of this peroxymonosulfuric acid, means potassium salt, or in short you can say this potassium peroxymonosulfate is the one of the component of the triple salt oxone, and actually this is the main component which displays its chemical reactivity, that is oxidant. Now question, how it's prepared? It's very important reagent. Actually this is prepared from oleum. This is oleum, or this sulfuric, means you may consider this a H2SO4 plus sulfur trioxide mixture. When it reacts with hydrogen peroxide, it produces this molecule. It is known as Carros acid or this peroxysulfuric acid. Now how this reaction happen? We know this hydrogen peroxide means HO, and by the way hydrogen peroxide is a very good nucleophile because the lone pair repulsion of these two adjacent oxygen. So it since it's a very good nucleophile, so what it does, it attacks the sulfur center, means this lone pair attacks here sulfur center, so it opens up and it come back and this leaves. So in this way what is produced? One, this H2SO5 plus another, it produces H2SO4. so this is the overall reaction. Now both are strong acids, so it reacts with strong base KOH and ultimately it produces a mixture of salt. Mixture of salt means potassium, this Carros acid, potassium salt, monopotassium salt, potassium bisulfate and potassium sulfate. So these three are produced, and here you can see that after the reaction, this peroxy means hydrogen peroxide, this part is introduced into the Carros acid. So this is the difference between sulfuric acid versus this peroxysulfuric acid or Carros acid. Now, so a simple question may come in your mind, why do not we directly use potassium peroxymonosulfate in the reaction, since it is the main component for this reaction? Or why do we use two additional reagent, means this potassium bisulfate or potassium sulfate? Because whenever we talk about any chemical, we try to reduce the uses of chemical as minimum as possible, because in every case there is some chemical wastage, disposal issue, green chemistry concept, etc. But in this case, why these two chemical, means this bisulfate and sulfate, are used? This is because, student, this triple salt mixture as higher stability, means this oxone has higher stability than this KHSO5, which is the main component. This is because the this oxone is actually a solid triple salt, so it crystallizes. When something crystallizes, it is, you may consider the maximum purity is there in the crystal. Second, its decomposition is less compared to the KHSO5 itself. So it is safe, it is easy to handle, it is solid. So that's why. And another thing, student, please remember, is it is very easy to handle crystal, because for example you need 500 milligram crystal for your reaction. You can easily measure or take 500 milligram of crystal from a solid, means a crystalline material, but if it is a liquid material or it's amorphous, hygroscopic, that much it is very difficult to take. And you know, stoichiometry is very important. We should not use excess, we should not use less. Now the second most important question, why oxone is oxidizing in nature? So this is the structure of this, actually the whole mixture is structure of oxone, and the main active component is this potassium persulfate. Now, why this is oxidizing? This is because the presence of these peroxo group. Why? Because if you look at the oxidation state of other oxygens, all are -2, all are -2 except these two oxygen. And what's the oxidation state in this case? This is -1 and this is -1. That's why they prefer to go to -2 oxidation state, and that's why they oxidize someone. So a simple, you may think, sir, what is the fate of this part? Okay, this potassium peroxymonosulfate after oxidation, means after it oxidizes someone and it itself gets reduced. So what happened about it? It simply formed into the corresponding sulfate, means this part gone and the remaining this oxygen became -2 oxidation state. So this is the overall, means the peroxo linkage is destroyed. Second thing, if you look at this compound also have this lone pair repulsion or alpha effect. So like hydrogen peroxide, this is also not that much stable, means it is also a reactive chemical. Now if I say you that, student, can you compare which one is more reactive, hydrogen peroxide or this, means from this lone pair repulsion point of view? Obviously this KHSO5 is relatively more stable. Why? Because if you look at the structure of this molecule, you can see there are actually 4 lone pairs on this oxygen. So what can happen? These lone pair could be donated here and it could be opened up. So and one canonical form possible. So this canonical form possible, O minus K plus, and along with that is O minus, this is O, this is OH. So what was the problem previously? This lone pair repulsion. In short, electron density versus electron density repulsion. Now one lone pair is gone because of this conjugation with the central sulfur oxygen bond. So that's how it is stabilized to somewhat. Okay, and in this case it reacts and ultimately ultimately it oxidizes someone. And in this case you can see the standard electron potential for this peroxymonosulfate is plus 1.81 volt, and in this case the half reaction is, what happened, this HSO5 got reduced, means it takes electron, okay, and ultimately it produces this bisulfate. So means the oxidation state of this oxygen was -1. Right now after taking electron it became -2. Now in this context some question may come in your mind that, sir, we say this reoxidation is good, this is bad. In this way this is good, this is bad. But what is the ultimate, or what is the greenest oxidizing agent? Student, the greenest oxidizing agent is atmospheric oxygen. Okay, because we have a huge amount of oxygen in our atmosphere, and more specifically if I say this is triplet oxygen. Okay, because there is another version of oxygen which is singlet oxygen. This is a very poisonous oxygen and very reactive, and I have already discussed a dedicated lecture on this. So we can't survive if the environment became full of this singlet oxygen. So the best and greenest oxidizing agent is singlet oxygen, and that's why industry prefers to use oxygen gas if they can, means if scientific methodology is available. Now another confusion may arise in your mind, which structure is correct for KHSO5 or why? Because I can say that this is this or that. Please remember, no, why, that is, if you know the answer why, then you can remember it more efficiently. Actually the right structure is this one, this KHSO5. Now question, why not, means what is the difference? If you look at these two, in one case this S attached oxygen is O minus, in other case this peroxy oxygen is O minus. What is the issue? Why? Because if you look at the acidity means stability of conjugate base. Okay, means in this case you can see that the lone pair of electron, means here the lone pair could easily be delocalized with either this SO bond, this SO bond, both. So two equivalent resonance possible in this case. But if you look at this molecule, there are 3 lone pairs of electron. Now question, can it delocalize? Obviously no delocalization possible, means charge is confined on this peroxyoxygen. So that's why this is less stable. So consequently anion will be concentrated, or negative charge will be concentrated on this oxygen, or these you can say these, you can say this, because three are equivalent due to resonance. So that's the thing, I guess you understood. A similar question in this way come in your mind: which one is more acidic between water and hydrogen peroxide? Because if you look at water, this is water, and what is hydrogen peroxide? Hydrogen peroxide is HOOH. Now actually hydrogen peroxide is slightly more acidic compared to water. This is because there are one hydrogen for one oxygen, but in water two hydrogen for one oxygen. So you know oxygen is more electronegative, so that's why if it get means this bond is withdrawn, so in case both are withdrawing means both side two hydrogen, and here for one oxygen one. So that's why please remember. Now another question is oxone acidic or basic? Now you'll say that, sir, you told some time before it's a salt. Now your question, why you are asking about acidic or basic? Because the structure of sulfuric acid, if you look, there are two replaceable proton. So actually this sulfuric acid is a dibasic acid. So two things possible. It can produce single salt, means monosubstitution, or disubstitution. Monosubstitution is this potassium bisulfate, and this is called acidic salt. In some cases, for example, where you need some acid for reaction, I guess in organic chemistry, sometime in case of aldol condensation also, you have seen that KHSO4 is used as the source of acid. Why? Because sulfuric acid is a strong acid. So KHSO4, if you look, then one side is K, this minus K plus, but still there is another OH, and that could be protonated to give acid. So that's why it would be disalt also. So one part of this oxane is mono salt, means acid salt, another is neutral salt, means K2SO4, and this is the peroxysulfuric acid. And by the way, if you compare, as I told, this is a very weak acid because the corresponding oxygen anion or conjugate base is not stable. So if I overall ask you, is oxone acidic or basic? Oxone is acidic in nature, and the acidity is mainly contributed because of this part, means KHSO4, potassium bisulfate. Now since the same thing, as I told, which part is responsible for its redox property, as I have explained this part. Now this slide I have given you to remember some other reagent which you used or read previously, like MCBPA, MCPBA, metachloroparabenzoic acid. This metachloroparabenzoic acid is used for electrophilic epoxidation or epoxidation of double bond. I have already discussed this thing previously. Not only that, urea hydrogen peroxide nitrile, this is also an electrophilic epoxidizing agent, although if you look at hydrogen peroxide, it is nucleophilic epoxidizing agent, means it epoxidizes the alkene attached to electron withdrawing group. So this thing, even if you look at this sharpless asymmetric epoxidation, where titanium tetraalkoxide isoperoxide, one asymmetric ligand, and along with that this tertiary butyl peroxide is used. What message I want to give? Then in all the cases, this peroxy linkage is responsible for its acid, this redox property. So this -1 oxidation state of peroxide is reduced to -2, and the organic material, for example this double bond, got oxidized, means oxidized, or you may say epoxidized to corresponding epoxide derivative. So this is the overall thing you should remember. Now let's come to a summary about the chemical property of oxone. I shall come some example later on. Now if you react this with trialkylamine, it forms amino, means these N-oxides. If you oxidize aldehyde, carboxylic acid, if you do the reaction in alcohols, then you may get this ester, or this is actually, you may consider this is the acetal of aldehyde. So not only that, it oxidizes sulfur to corresponding this sulfate derivative. So it means you may consider this is a dioxidation, okay, further oxidation of DMSO. Not only that, it can oxidize triphenyl phosphine into corresponding triphenyl oxide or trialkyl borate to this borate ester, and from that you can get what? Alcohol. Just remember the hydroboration oxidation concept. And the final one is epoxidation, as I told just some time before, similar chemical property to prepare epoxide. So these are the overall summary, and let's come to the MCQ. What is oxone? Oxone is nothing but it is a triple salt. So option number 1 is the answer. In our other case here, 2 equivalent KHSO4, no, it's a triple salt, so no, no, no. And remember student, this is not oxone, this is actually Carrot's acid, as I told some time before. So this is the end for those high school students for IIT JEE and NEET examination. Now I shall move on to some higher studies. Now for that purpose, first one MCQ. What is the major product of this reaction? 4 options are provided. I request you please pause the video and try by yourself, and definitely at the end you will get the right answer. Now let's go. Now if you look at little closely about the oxidation, the aldehyde in presence of oxone and alcohol got oxidized into, this is ester, okay. And other case, if you look at, this is acid, and this oxidation is done in presence of DMF. So strictly if you change the solvent, you will get the different products. So student, please try to understand this thing little carefully, and for that purpose I believe mechanism is the best. So what happened if you take a aldehyde, for example this one, and if you react with KHSO5? Why this reaction happens? Because if you look at the structure, this has this structure, okay. So this is the structure, and in this case this is O minus K plus. So this part is not responsible. So sometime before I told that due to this lone pair repulsion, which is called as alpha effect, the nucleophilicity of this peroxyoxygen increases. And which oxygen will attack? Obviously this will attack. Why? Because the other one is inside, so more crowded. Second thing, the lone pair is in conjugation with sulfur oxygen double bond. So these oxygen will attack here. It's better nucleophile, and aldehyde, so it will attack and it will open. So in this way, after proton exchange, it will produce this hydroxyl, and this is. And next step, as I told that these oxygen bond is not stable. So what happened? The lone pair of oxygen from this alcohol, means this addition product, will attack here, and this hydride will migrate, and this will leave. And in this way, see, previously this is also the addition product. He sees the addition product, but still not till now no oxidation reduction happened. But in this case, the aldehyde got oxidized. This part is oxidized, and this part is, means this peroxymonosulfuric acid, this is got reduced, okay. So this part I guess you should understand little carefully, in which state and why this has happened, because of this hydride migration. Now so this is in presence of alcohol, sorry, this is in presence of DMF, just some time before I told. Now in the next step, in presence of alcohol, what happens? First, in presence of alcohol, what acid can, what can a reaction expected? Because just try to remember student, what is the nature of this reagent? This is actually acidic, and we know for hemiacetal or acetal preparation could be done in presence of acid. So reagent contains some acid, medium contains alcohol and aldehyde. So hemiacetal formation is expected to happen. So first, this aldehyde could be protonated by the proton, and second, methanol will attack, and ultimately it will produce hemiacetal. I have already discussed a dedicated lecture, you may visit for better understanding about this process. Now in the next step, what you can expect? Now simple thing, just this acetal formation, this hemiacetal formation is actually a reversible process. So what can happen? This OMe group can leave, option number 1, or what another option possible, that this lone pair of OMe can push. Medium is actually student, the medium is acidic. So first step, this proton could be protonated and it can leave. So that's the mechanism. Please visit the corresponding video. I shall provide the link in the description box. So now it can come, and what it can produce as an intermediate, you may consider that R, this is double bond O, OMe with a positive charge, and there is hydrogen. So this is also a type of carbonyl. Now just remember, just try to understand this structure again, similar like the previous one. This lone pair of oxygen can go and attack here, simple like the previous. So it will produce this intermediate, and similarly this oxygen also has lone pair, so it will push and the hydride will migrate, and like similar mechanism it will produce KHSO4, and this is OMe. Now question, why this is formed ester? Because initial stage this OMe was added because the reaction was carried out in methanol as solvent. So I guess you have understood the mechanism. Now so let's come to the second example. Just some time before we have discussed about this aldehyde, and for that case hydride migration happened because hydride had the maximum migratory aptitude. But if you take ketone, both sides are alkyl, so that time these al means vinyl group migrates using same condition. See, this is DMF and dry. So hydride means this part will migrate, so these al means vinyl part will migrate, and ultimately it will result a vinyl ester derivative. So please clear this concept. In case of aldehyde, changing the solvent, if you take methanol it will result in the, means if you take alcohol it will result in the corresponding ester of the alcohol. If you take simple DMF it will result in carboxylic acid, but whereas if you take ketone you will end up in a particular ester, and in this case it resulted in this vinyl ester. And question, why this is dry? Why you need dry? Because if you have moisture in the reaction medium you may get some amount of acid as your byproduct, so which we don't want. So that's why anhydrous condition means dry DMF needed, means solvent do not have DMF, and not only that, nitrogen environment the reaction is carried out such that the reaction mixture can't capture moisture from the atmosphere also. So this is, and next N-Oxide preparation. So I am not student focusing on Oxone tab part, so just I have explained. So let's focus on the actual chemical reaction. Actually this is actually a acridine derivative. I have already discussed a dedicated lecture on acridine preparation, you may visit. So this acridine preparation, there is a lone pair, and this lone pair is in sp2 orbital, so it can act as base or as nucleophile like pyridine. So you may consider it as it's a substituted pyridine derivative, means penta substituted pyridine. So it oxidizes like the N-Oxide formation I have already discussed in many lectures. So it oxidizes in presence of this, and ultimately it converted into this N-Oxide. And by the way, there are two epoxy oxidation, two oxygen from hydrogen peroxide, one came here. So what is the fate of this? A similar, this KHSO4 potassium bisulfate, and see the yield under normal condition is got. And so this is the case of N-Oxide oxidation. Sorry, this is next is oxidation of sulphide. See, this also oxidation of this sulphide into corresponding this dioxo species. Okay, and another thing, when you are doing a reaction and it is given, but this is not given in the option, instead of that is given this. So this is the F and this is, means this is air. So such type of, then student you must also be careful, because first it converted into this, second it comes here. So whenever you get any question, try first you know what is the chemistry and what was given for you in the MCQ or question, and based on that you decide. If this is given, that's the best thing, but sometimes teachers give some means may twist the question. So if you understand this, I guess you will be able to answer. Now question, why sulfur got oxidized? What is the need of sulfur to be oxidized? Because we know this sulfur has lone pair, two lone pair, like simple oxygen, two lone pair, but sulfur has relatively less electronegativity, one number point, and second it's a third row element, so bulky, more means bigger in size, or you can lesser electronegativity, bigger in size. So what happened, this lone pair is loosely bound to the central sulfur atom, that's why that is oxidized by this part, means this oxone, and ultimately it converted into this S double bond oxygen. So this is the basic chemistry behind such kind of reaction. Now there is a sheep oxidation. This is another name reaction. In this case the alcohol is selectively oxidized to a particular enantiomer of epoxide. And why this happened? Actually, just sometime before we understand that alkene could be converted into epoxide using oxone, that part is understandable. But why this enantio selectivity? Because of the presence of this ligand. Why? See, if you look at this ligand is actually the this ligand is chiral. So presence of this ligand also provides another thing, that is chiral environment, and we know under this chiral environment, two enantiomers are treated differently and their reactivity is different. Under achiral environment, both could be prepared in same amount, but under chiral environment, they will be prepared in different amount, and someone get preference over another one because of the enantio purity of the ligand which we are using for the reaction. So that's why we get this. So this is the product. Now in conclusion, what you have learned today, Oxone is a very good reagent for oxidation due to the stability, simple handling, non-toxic nature and the low cost. This is a highly preferred reagent for chemists, and this is actually this is responsible for 2 unit oxidation, means it takes 2 electron, that's why it is responsible for 2 unit oxidation, and in this case the peroxy linkage is responsible, and this peroxy group is less acidic but more nucleophilic. This is due to the alpha effect. And finally, please remember this thing, crystalline compound are easy to handle than liquid, and they are very pure. So that's why during purification scientists prefers to do crystallization if possible. Now let's come to the second MCQ. What is the major product above reaction? By the way student, the answer of this question is option A. Now you will be confused why. Just read the reagent carefully. There has 5 mole% palladium 2. So it's actually gone through coupling reaction. What happens in this case? This palladium 2 first react with ligand. What is ligand in this case student? The lone pair of nitrogen is donated to the palladium 2 center. So this is the ligand. So if it is donated, what happened? This palladium came closer to this CH, and that's how this CH got oxidative addition, and ultimately it resulted in palladium 4 species, and this resulted in palladium 4 species. And this, after that, see, this ligand is coordinated, means it's a coordination bond. There is a coordination bond, carbon having a direct bond, means if I draw it little carefully, so this is, you can see the compound, this is the bromine, this is N and this is OMe, and here this lone pair is donated to the palladium metal, and palladium has direct bond with this carbon. So whatever are there, I am not focusing. Now in this case you can see this palladium is in higher oxidation state, means palladium 4 oxidation state, now attached to carbon. So you may consider that this carbon is delta minus, or you can say it is electron rich in nature, it's a carbon ion. Now you can say that sir, electronegativity of palladium is closer to carbon, so how can you say that this is electron rich? Because it's covalent in nature. I agree student this point, but remember, a metal carbon bond, if there is a slight difference in electronegativity, there is slight difference in charge. Point number 1. Second, see, carbon and palladium both are far away from each other in periodic table. So extent of overlap, if you look at for this bond, is not that much high. And what is the product? This is the oxone, and in this case it produces the product OAC, means in this case the palladium carbon bond is replaced by carbon oxygen bond, means here, and both are second row elements, so extent of overlap is more, so the product is stable. So that's why this center, means this carbon ion, you may consider is oxidized and ultimately produces this OAC. Now you student may confuse that sir, there is a Br, but whenever we see this carbon bromine bond in palladium, it undergo this. I agree student, but you have to check where the reaction can happen most easily. there could be infinite number of possibilities, but reaction will happen on that position where the reaction energy of activation for the corresponding reaction is minimum, and in this case this is. So this here the reaction will happen, and only this center reaction will happen. So option, why not other? So this option not possible. Now you can say that, sir, this can rotate and it can come also, but remember student, this center is not, is little more bulky, you may consider. So it is not a palladium metal, palladium atom itself, there are some ligands also, so bulkness is also a factor. That's why palladium will prefer this position, okay, this carbon center. Now third option, this bromo substrate, as I told, it's not possible. And fourth, reaction will happen after that. This is actually oxime, you can consider. It is hydrolyzed, but student remember, this oxime means the corresponding nucleophile is OMe. Means hydroxyl amine monomethyl ether. So this is a very good nucleophile, and the bond between this nitrogen and this carbon means this imine bond is significantly stable, and under this acetic acid condition, means under this condition it cannot be hydrolyzed. So that's why reaction will stop at this position. So now this is the end of the discussion. I thank you for watching, and if you really enjoy my content, then please help my channel to grow. And I have a request, if possible, please visit one of my another channel, that is chemistry, climate and chemistry, where I upload global warming and climate change related videos. So stay happy, stay blessed. See you in my next video.